Hello and welcome to the second set of problems on complex numbers. In this video, we will solve 10 more problems. And as I said in my previous video, there'll be easy problems till we solve like 40-50 problems and then difficult problems will start. So let's quickly go through 10 easy problems and try to make sense of these. The easy problems are there to practice so that you can reinforce your concepts. As to deal with the complex problems, you will need to have your basics solid. As I always say that you should pause the video when the problem is there, and when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only you look at the solution. So problem 11 says that if Z1 is equal to 2 plus 3i and Z2 is equal to 1 plus 2i, then find the value of Z1 by Z2. So Z1 by Z2 is 2 plus 3i by 1 plus 2i, and we want to get rid of imaginary. So like in last video, we multiply and divide with conjugate of denominator, which in this case is 1 minus 2i. So denominator becomes 1 square plus 2 square, that is 5. And numerator on multiplication becomes 2 minus 4i plus 3i minus 6 plus 6. So it is equal to 8 minus i by 5. Problem 12 said that if Z1 is equal to 9y square minus 4 minus I 10x and Z2 is 8y square minus 20i, such that Z1 is equal to Z2 bar, then find Z is equal to x plus y. So since we are given that Z is equal to Z2 bar, 9y square minus 4 minus I 10x is equal to 8y square plus 20i. This is the conjugate of Z2. So now we bring y square one side, we get y square minus 4, 9y square minus 8y square will be y square. Y square minus 4 minus I into 10 into x plus 2, because 20 this side comes with negative sign, so that would be minus 20. Now we compare real and imaginary parts. We have y square minus 4 is equal to 0, that means y will be plus minus 2, and x plus 2 will be 0, that means x is equal to minus 2. So our required complex number z is minus 2 plus minus 2i. Problem 13 says that find z if mod of z plus 1 is equal to z plus 2 into 1 plus I, where z is in complex number set. So we let z is equal to x plus iy. So mod of z plus 1 would be x plus 1 plus iy is equal to x plus 2 plus I into y plus 2. So mod will be square root of x plus 1 whole square plus y square is equal to x plus 2 into y plus 2. Now we compare real and imaginary parts. So this imaginary part has no corresponding value on left hand side. So y plus 2 will be 0, that is y is equal to minus 2. Now when we compare the real parts, we square this and we square this. We get x plus 1 whole square plus y square is equal to x plus 2 whole square, which is equal to x plus 2x plus 1 plus 4. This has come from y square, and right hand side is x square plus 4x plus 4. X square will get cancelled, so we will have x is equal to 1 by 2. So once we have x and once we have y, our complex number z is 1 by 2 into 1 minus 4i. Problem 14 says that find the modulus and argument of the complex number 1 plus 2i by 1 minus 3i. So as always, we get rid of imaginary terms and denominator. We multiply with the complex conjugate, 1 plus 3i in this case. So our denominator would be 1 square plus 3 square, that is 10. And numerator would be 1 plus 2i into 1 plus 3i. We solve this, we get 1 plus I by minus 1 plus I by 2. So that means modulus of z would be minus square root of 1 by 4 plus 1 by 4, because this is minus half and this is half. That is 1 by root 2. Now let's verify something over here. Okay. So 1 into 1 would be 1. And 3i into 2i would be minus 6. That is minus 5. So real value will be minus 5. And imaginary will be 2i plus 3i, that is 5i. So 5 will be common, so this is correct. Now argument of z would be tan inverse minus 1, because minus half by minus half. So that would be minus 1. We will have argument as 3 pi by 4. Note that here x is negative. The real part x is negative, so this will be in the third quadrant. If x would have been positive and y would have been negative, then it would have landed up in the fourth quadrant instead of second quadrant. Problem 15 says that if x minus 3 by 3 plus I plus y minus 3 divided by 3 minus I is equal to y, where x and y belong to real number set, find x and y. So we take LCM and we bring, sorry, this should be I. This is incorrect. So we take LCM and we take the denominator to right hand side. We get x minus 3 into 3 minus I plus y minus 3 into 3 plus I. And 3 plus I and 3 minus I are complex conjugate. So that becomes 10I. And we solve this. We get 3x minus 1 we plus I into 3 minus x plus 3y minus 9 plus I into y minus 3 is equal to 9. We compare real and imaginary parts. We get 3x plus 3y minus 18 is equal to 0 and y minus x is equal to 10. We solve these two linear equations. We get x is equal to minus 2 and y is equal to 8. Problem 16 says that what is the real part of 1 plus I to the power 50? So what we do is first we evaluate 1 plus I whole square. So 1 plus 2I minus I, sorry, this should be minus 1. This is not minus I, this is minus 1 because I square is minus 1. So minus 1 plus 1 gets cancelled, we get 2I. So we can write that 1 plus I to the power 50 is equal to 2I to the power 25. Now this becomes 2 to the power 25 and I to the power 4 into 6 plus 1. So 24 is multiple of 4, so 24 powers is equal to 1. So we get 2 to the power 25 into I. So the real part is 0 because this is purely imaginary number. Problem 17 says that if a complex number is z such that z plus mod of z is equal to 2 plus 8i, find the value of z. So we let z is equal to x plus iy, then according to given x plus iy plus mod of z, that is square root of x square plus y square is equal to 2 plus 8i. Now we compare real and imaginary parts, we get y is equal to 8. So straight up we have solution for y. And from real part we get x plus square root of x square plus y square is equal to 2. We bring x to one side so that we can conveniently square it and we get x square plus y square, that is 64. This will become 64 is equal to 4 minus 4x plus x square. So x square will be equal to x is equal to minus 15. X square will get cancelled. So 64 comes this side, becomes minus 60 and this goes that side. So x is equal to minus 15 and z is equal to minus 15 plus 8i. Problem 18 says that find the sum of the sequence I plus 2i square plus 3i cube plus up to 100 terms. So this is an arithmetical geometric progression. You can see the coefficients are 1, 2, 3 up to 100, which is an arithmetic progression, and that is combined with I plus I square plus I cube. That is a geometric series. So if you recall how we evaluate arithmetical geometric series, then we multiply this s with I. That becomes I square plus 2i cube up to 100 I to the power 101. So we subtract the corresponding terms. We get s into 1 minus I is equal to 1 plus I square up to I to the power 100 minus 100 I to the power 101. So this is now a geometric progression. We solve this 1 minus I to the power 101 by 1 minus I. This should be I. Now we take out this 1 minus I and put it in the denominator. We get 1 minus I to the power 101 by 1 minus I square minus 100 I to the power 101 divided by 1 minus I. Now you can simplify this further. So I have left that for you. Problem 19 says that find the value of the sum 1 by 1 plus I plus 1 by 1 minus I plus 1 by minus 1 plus I plus 1 by minus 1 minus I and so on up to n terms. So we consider T1 is equal to 1 by 1 plus I plus 1 by 1 minus I plus 1 by minus 1 plus I and so on. So we sum these two terms, so we get 1 plus I plus 1 minus I and divide by 1 square minus I square. So this will become 2. And similarly, this will become 2. Now I will get cancelled here, I will get cancelled here, we will get 2 by 2 plus minus 2 by 2, which will be 0 because this is 1 and this is minus 1. Our second term is nothing but we take 2 here and the product inside the brackets is the second term. So this product will be 0, this sum will be 0, so T2 will be 0. Similarly, all other terms will be 0 and sum of the given sequence is 0. Problem 20 says that find the product of real parts of the root z square minus z minus 5 plus 5i is equal to 0. So for solving this problem, you will need to understand how quadratic equations work. So you can skip this if you don't know quadratic equation yet. So what we do is we find out discriminant. Discriminant is b square minus 4ac, which is 21 minus 20i. And for roots, we will need square root of d. So we square root, and from square root formula, we get plus minus 5 minus 2i. Once we have the square root of d, we can find z is equal to minus b plus minus square root of d by 2. So we get two The roots 3 minus I and I minus 2. The real parts are minus 2 and 3. So the product of real parts is minus 2 into 3, which is minus 6. So with this, we come to the end of 20th problem, and we'll further go on solving 10 more problems in each video. If you have found this video useful and informative, then please subscribe to the channel and like the video so that it can reach many more students like you and they can benefit from this as well. So do the good thing and subscribe the channel and like the video. If you have a comment or a suggestion or you want to correct something, please let me know in the comments. And if you want videos on certain topics, that also you let me in comments. So thanks a lot for watching the video. Enjoy.